I'm gonna give you just a brief overview about myself, and maybe after that you can also introduce yourself so I get to know you. Okay, so my name is Martin Yanev. Okay, I've been instructor in Fitchburg State since the last spring. Okay, normally I'm working as a software engineer in the pharma industry. Okay, but as you can see, I also have a background in aerospace. So I come from aerospace background. I work in quite a few aerospace companies in Europe, and now I'm working in Massachusetts as a software engineer. Okay, so now the first thing I want to talk about is why do you need to know computer and network security. Okay, so in this course we're going to learn not only about the theory and about all the protocols and standards, but also I want to introduce you to some practice. Okay, so we're going to see how messages are transmitted over a network and what measures we're taking for those messages to be received in secure way. Okay, so we're going to learn about this, and at the same time the main project, which I'm gonna go over it in a few seconds, the main project for this course is going to be on Python, so you'll be able to implement the theoretical knowledge that you get into practice. Okay, so we're going to do something related to encrypting and decrypting messages, making sure that we maintain data integrity. And of course, you might not be familiar with those terms for now, but hopefully after today's presentation, you will know them. And of course, in every next lecture, you're going to learn more and more on how to implement computer and network security. So before starting, also my office hours, you can meet me Tuesdays and Fridays, 5 p.m. to 9 p.m. EAT. Okay, so if you have any questions, any issues with the quizzes or the assignments or anything else that you want to discuss with me, I'm always open, to discuss and help you out with anything you might have. Okay. And finally, of course, it's very important for you, I know, to get a job eventually, right? This is the goal of all of you, and to be renowned in the software space, right? So if you want to connect me in LinkedIn, I'll be very happy to also endorse your skills there, and help you out with your career in every way possible that I can. Okay, the initiative though should be from your side. Now, before jumping into the presentation for today, I'm just going to review the syllabus for this course, and will present you with what and how I'm going to be grading you. Okay, so as you can see here in the course outline, you have all the topics that we are going to be covering this summer, and those are 5 topics, as you can see. So today we're going to cover computer and network security fundaments, and then from the next week we're gonna move to authorization and authentication. Then we're gonna practice applied. So we're going to practice how to do semantic encryption and public key encryption. Okay, we're gonna do cryptography using Python, and also we're gonna explore hash functions, which is very interesting. Then we're gonna move to firewalls. So you're gonna learn what they are. Probably for most of you, as it was for me before, firewall is just some word that you see on Windows when you started, and it just asks you, do you want to implement a firewall or not? So now you know what it actually is. And we're gonna finish by cloud computing, technology security. Okay, it's a very modern space. These days we're having different types of clouds like Amazon, AWS, of course, and so on. So here is how I'm going to grade you for the course. Now you can see that those are all the topics. Okay, and after every lecture, we're going to have a quiz that is going to be on this specific lecture. Okay, so I know that for students it is difficult. The most difficult task normally is to find information rather than studying it. So I'm going to provide you all the information that you need in Blackboard. Okay, so in Blackboard, what you're going to get is the presentation from today, as well as a readable PDF with everything you need in order to solve those quizzes. Okay, so after every lecture, you're going to have a quiz based on the lecture. Okay, so for the summer term, we have, as you can see, 4 quizzes, and there will be one assignment which is going to be based on our practical exercises that we're going to do with Python. Okay, the practical exercises that we're going to be doing are going to be in a web IDE, so you don't need to install anything in your computer. They will be easy and straightforward, okay, if you follow the theoretical material. So you're also going to be great on this assignment. And here, what you can see is the points that you're getting on the different quizzes and the assignment, which is pretty much determining your final grade, okay? And those are the grading points that we're going to implement. So last thing I would say, let's go around the table. If you want, one by one, you can introduce yourself to me. I know that it's not all of us today, but for sure I would like to get to know you. So yeah, let's start top to bottom how it appears here on my screen. So Chauncey, sorry, how is your name? Is it like this or
Yes, Chauncey.
Chauncey?
Let's see. Do you have any set specifics we should say, or just anything to introduce?
Yeah, just to introduce like where you're from, what are your goals, maybe that way I will know how I can help you with, your career and your goals.
Okay. Yeah. So my name is Chauncey, and I've been working in education for the past I don't know 12, 15 years, and I've wanted to switch into something related to computers. Uh, I hopefully maybe a software engineering, but I'm curious about AI and maybe your thoughts on how that will affect future software engineers. Things that I've read lately don't sound very promising, but coming out of education, work in a K-12 school and currently in Thailand, so I'm connecting to all the classes remotely from online. I'm looking forward to meeting other classmates as well.
Nice to meet you. Nice to meet you. All right, let's go next with Bawa. So yeah, okay, I see.
Yeah. Hi everyone. My name is Balakrishna. I am from India. Um, I have started in Fitchburg. It is like previous year fall, August 2023. Now this is my third sem. Mm, Mainly, I have taken this course to know about the network and security fundamentals. It's like previously, after my graduation, undergraduate, I have done a job in Accenture Solutions in automation in using Selenium, using Java. I need to. It's like I am from electronics and communication background. I want to know more about the computers, so I am doing now masters in computers.
Great, nice to meet you. Yeah. Okay, so next let's go with Manisha. Hey Manisha. Can you hear us? Okay, I'm just gonna move forward then. Manisha, I see that you removed your mic. Yeah, okay.
Hey, hi, I'm Manisha. Last fall, I joined, so in Pittsburgh State University. So I'm having 2 years experience in software development in India in TCS, and right now I'm doing CNS. Yeah,
Nice to
thank
meet
you.
you. Nice to meet you. Okay, so next one, Harishwar.
Hi, myself Harishu, and I'm from India. And I have joined the Pittsburgh State University in the fall 2023. And this is my third sem. So I'm looking forward to learn more about computer networks and security.
Great, great. Nice to meet you.
Nice to meet you.
Okay, so next one is Sreni Vash.
Hey, hi. Hello, everyone. Good evening. This is Srinivas Ishwaroju. You can call me Srini. About myself, I'm into electromechanical industry more than 18 years. I have been working as a subject matter expert for car audio. So I do design infotainment amplifiers for the future vehicles. So these days I see like connected cars. You might have heard vehicle to vehicle communication, vehicle to object communication. So I took this course to like see how the network feasibility and security we can maintain and more reliable communications with objects, vehicle to objects. I hope this course will be utilized for my next prototypes or ideas to leverage more products.
Nice, great, nice to meet you.
Same here, Martin.
Okay, and finally we have Vamsi.
Hey, hi, hello, how are you, Martin?
Hey, I'm good, I'm good.
Yeah, thank you. This is Vamsi. I'm from India. I have completed my bachelor's in computer science, and I continued my computer course in the master's also. Currently, I'm running with my final sem with the computer network security (CNS). This is the final course for me.
Wow, it's been, I guess, a long journey, right? So nice,
Yeah,
congrats.
yeah. I'm a transfer student too.
Okay, nice, nice.
Yeah.
Nice to meet you.
Thank you very much for this.
Nice to meet you.
Yeah.
Okay, so firstly, I'm just going to answer about the question about the AI, if it's gonna replace us. I mean, my thoughts on it. Actually, last year I wrote a book on how to build AI applications using the ChatGPT APIs with Python and those things. Actually, this is what we're teaching now in Fitchburg. So if you're interested in that course, it's going to be on the fall, as I said. But the way I see it currently is that the AI is going to be used as a tool, right? So so far, I don't know how the future is going to be, but so far, the AI is not that advanced to be able to figure out and write like a complete operative software and complex software just by itself. However, it is a very good tool when you are building the software, but you need to know what you want to build, what are the requirements, what are the features that you need, and then you can use the AI as a tool to build the software. Okay, I know this because I've done it myself last summer just for an experiment, and it's a great tool for that. So what I think is AI is not going to replace the software engineers, but for sure the software engineers that know AI and are familiar with AI are going to be way more efficient. So this would be a skill that is definitely more preferable for employers, right? So if I make a company, I would want to hire people that know how to use AI, because I know that they will be more productive for me, which eventually will make me to generate more revenue with less people, right? So this is the idea. But no, I don't think it will replace software engineers. Maybe it might reduce the positions, but also it will open new businesses for the software engineers as well. So this is how it looks currently. We're gonna see how it's going to shift in the next years. Okay. All right. So now let's focus on the lecture for today. So let me just remove the syllables. Okay. So as I said, today we're going to focus pretty much on what network security is, what are the main terms that are involved in network security that we're going to use throughout the course, so you can get some introduction, right? Okay. Okay, so the idea for security, and it is very good idea for you to try to imagine what's happening in the computer science space from real life events, because everything that is created, the communication between different systems, is created based on live events. For example, the communication between two machines is exactly based on the standard mailing service, right? So if you want to send a message from a computer to another one, the things that you need to do is to write the message, okay, pack it in an envelope, send it with a postal service, to the destination. Then the destination opens this message and it reads it. It's the same with computers, right? So you're creating a packet, then you send it through the network, so the network transports the packet to the receiver, and then the receiver gets the packet. Okay. If you're sending a letter and you want nobody else to understand what's on your letter, you can encrypt it, right? So you can have some encryption protocol that, let's say, you can say A equals to star, B equals to dash, right? You can have this code in your home, and the receiver can have the code in their home. So only you and the receiver will be able to decrypt the message in real life. So with the computers, it's exactly the same. We're going to use, of course, more advanced algorithms, but those algorithms are already created, so you don't need to worry about those. But what I'm trying to say is that everything in the computer networking is pretty much taken from real life events. Okay. So network security is a process for protecting an object, any object, in our case a computer object, from unauthorized access. Okay, so there are two states with which you can protect an object. Okay, this is the physical state and the theoretical state. Physical state is what's real, okay, what actually protects the object, and the theoretical state is imagine this as the fake belief that everything is protected and nothing can go wrong. Okay, so if we want to do an actual protection of an object, okay, in the physical state, okay, the first thing that we need to do is to protect this object. Okay, so protection means that we try to set some defense mechanisms so we're protected, okay, and nobody can access our system. Okay, the prevention is a process of trying to stop the intruders to come into our system. Okay, then we have the detection, and this is when the intruders are already in our system. What do we do in order to find out where the problem is? Because we cannot fix the problem if we don't know where it is. And finally, this is the reaction, or what do we do in order to remove the problem from our system, okay, to remove the intruder. Okay, so as I said, there are two types of security, and the second one is the theoretical state, and those are some of the things that we all do, imagining that our systems are secure, right? So you can see them listed here. Okay, so we're having hidden keys. For example, we have a key that is encrypted, and we believe that nobody else has the encryption to decrypt our messages, right? So let's say when we send a message from our laptop to another one, we believe that nobody else can decrypt it and read our messages. Imagine this if we're sending a message on Facebook, right? You don't think that anyone else can read it. We sometimes use default credentials for many different websites, trusting to those websites that they are not going to read the credentials. Actually, if you're into front-end development, you would know that it is very easy for anyone that has a website just to create a field, write on the top password, and then in the backend allocate wherever you write in this field into the database so he can get your password. This is very simple to do. So for this reason, of course, you should be using websites that are trustable, but we don't always do that. We just believe wherever we visit is trustable, right? Sometimes, and this is actually very common for applications development, we're keeping the API keys, or because when you create an app, you use different services in your application which are accessible by API keys. Normally, we hold this in a separate files, and we believe that nobody else has access to those files, right? But this is, of course, not always the case. Okay, so those are some things that we should, of course, be careful about, and we're going to explore some technologies that are actually really making those fake feeling of security in these days actually to come to reality and to actually be secured and to be actually able to trust most of the sources we use. Okay, so we're gonna go over those as well. Now, so since we have a security, of course, we can separate the security into some different areas. Okay, so this is why I posted on this slide. We have a computer security, network security, and information security. So in the computer security, the main thing responsible for your computer security is, can somebody tell me what? So what is the thing on your computer that is the most responsible for securing your computer from pretty much anything? No ideas? So, yeah.
Why don't you mention firewall earlier, like from external or?
Yes, this is a part of the bigger thing, so that's correct, yeah. Firewall, and the firewall is part of the operating system, right? So normally as a user, you won't expect to be responsible for the firewall and to go into the details how to activate it, but what would you do? You would purchase your device with a specific operating system, and the people that built this operating system should ensure that it is secure. Okay, the other reason for that is that all the applications that we use, they are one level under the operating system. Okay, so firstly we have the operating systems, and then using sockets we're connecting to the application. So if the operating system is not secure, okay, then there is higher level of vulnerability for the applications. And then network security. So network security is protecting the paths where our messages are traveling from and to. If you're using a Wi-Fi network, so most of us do that, okay, messages are transmitted through air. Okay, so what technologies we have, so nobody can intercept our message, right? After your message goes through your router into the internet service provider, then it goes through the wire. So what do we do to protect those the message traveling through the wires and not allowing anyone to access the message, right? In fact, there are many applications even on your phone. I don't know if you watched recently, the CEO of TikTok was questioned by the US government, okay? And what they asked him was, is TikTok actually accessing the Wi-Fi network? Because if you have an application that accesses the devices on the Wi-Fi network, it can get a lot of information from those devices, not only from your device. Okay, so this is why it is good to separate the network security and the computer security. Okay, and information security, I put it here because we need to also take a look specifically at the information that we're using. So how do we store it in a database? Is that the database safe? Are we the only ones that are having access to this database and to this information? Okay, for this we're gonna use authentication, right? So we can verify that we're who we are. Okay, so another way to look into security is to look into hardware and software security. Okay, so obviously hardware is, let's say, the motherboard of your device or the motherboard of any device that you're using. So this includes also hubs, switches, routers, those elements that are building your local network. Okay, so if we talk about software, this would be, the application software, the browsers, the client server protocols that we're using. So we're going to look into the network security mainly from the software standpoint in this course, right? But it's also worth mentioning that your hardware can also be intercepted. For example, if somebody gets an access to your keyboard or mouse, okay, this is also this person being able to access your complete device, right, to control pretty much everything there. So the next thing that we're briefly going to talk about today, and of course we're going to talk in more detail during our next lectures, this is the authentication, okay, or how do we know that we provide the correct information to the correct user. Okay, so if you're building an application, for example, in Python you can use a framework called Django. I don't know if some of you are familiar with it, but with that framework, for example, you have a built-in user database. So easily you can allocate and to specify resources to a specific user, to relate resource to user. Okay, and I just put here a few ways to authenticate a user. Okay, so this is obviously with username and password, which is the most common one. Facial images, our iPhones are doing that, right? We have the FaceTime. Fingerprints used by some other phones. In many situations, companies are using location. So for example, on your bank application, they might track your location from your phone, and if there is a transaction done in another country, obviously they might cancel it or they might hold it. Okay, so this is very common for the banking industry, and also this is more common for the companies. Like when you go to the office, sometimes you have identity card with which you gain access to the systems, right? Okay, so now let's talk about three very key terms that are part of the security space. So those are confidentiality, integrity, and non-repudiation. So firstly, we're going to talk about confidentiality. So I know it's written here, but who can tell me what confidentiality is? Where do you want something to be confidential? What that means? What do you think? Anyone? Come on, confident. Be confident, guys. So confidentiality. Okay. Okay, we're gonna practice this a little bit more. Okay, yeah, I'm listening.
It means that you have something that is kept safe between certain people that you trust, and you know that it's not going to go beyond those people.
Yeah,
and you
exactly.
trust that they won't share it.
Exactly. So yeah, you want to keep information just between certain people, exactly how you said. So this means that we want to keep data away from third party. Okay, so how do we do that in the computer and networking space? So in the computer and networking space, we do that using encryption protocols. Okay, so I don't know if anyone have heard about sniffers. Is anyone familiar what sniffer is? Or if you say to sniff a packet? Any ideas? No. Okay, so sniffing means exactly how it sounds, right? So you're sniffing or you're just like smelling something and pretty much get the information without actually interrupting the communication, right? So let's say you're sending a message using Facebook, for example, and while this message is traveling, on the way there, somebody reads the message, okay, packs it again, okay, and the message gets delivered. So everything is good. Nobody notices that anyone got the information. So those are sniffers. And it's very easy to write sniffer softwares, very easy to capture packets and to get the information from these packets. Okay, so in order for us to prevent that, this is why we need to encrypt the messages. Okay, so we need to have some cipher code, okay, with which we encrypt the plain text. Okay, so we have a plain text, we encrypt it, we send the cipher text. This is how it's called, the encrypted text. We send the cipher text to the receiver, and then the receiver has exactly the same encryption technology on their location, and then they decrypt the text. Most normally, yes, somebody raised a hand.
Yeah, well, I figured I would ask about the sniffer. If they can sniff a message as it passes by, is it possible to just copy the contents of the message without anyone noticing?
Yeah, exactly. So this is what they're doing. They're just copying the message without everybody noticing the exact message. Okay, so this is possible, right? And yeah, as I said, why this is not happening every day? This is not happening because we implement. So actually, most of the vulnerabilities on the internet, I mean, they still exist, but the very big vulnerabilities that came to reality that actually crushed very big companies happened around the years like 2000, 2003, when the companies were still new. You know, the space was still new. There were not that many secure protocols for communication. Okay, but these days we're using pretty secure protocols. And pretty much how it works, normally the sender and the receiver will have one public and one private key, and they will use those keys to encrypt and decrypt the messages. Okay, and later, of course, I'm going to also talk about the specific protocols that we're using specifically for web communication. Okay, so the next term that is very important for you to know is called integrity. Okay, so can somebody tell me what is data integrity and how is different from confidentiality, right? They might sound similar, but they're actually very different. So integrity makes sure that the data that we send to the receiver is not edited. Okay, so while the confidentiality makes sure that nobody gets the data, integrity makes sure that even if somebody gets the data, he cannot edit it in any way. So how is that protecting us? Well, that protects us. For example, if you want to send a payment of $10 to somebody, he can change the message and make this to $1,000, for example, right? So this is not a good thing. So we need to make sure that we maintain data integrity. And this sounds very vague, but how does it work in practice? So when you send a message, normally you pass it through some algorithm or some mathematical function, okay, that makes this message look like a code that nobody can understand. This is called a hashing algorithm. I don't know if you heard about hashing. So the hashing algorithm changes the message and makes it in a code that cannot be altered, or if some part of this code is removed or changed, this is not going to change the actual message, or it will change it in a way that it will be obvious for the algorithm that something has been changed, right? So the message will normally get resended, okay, and thrown to the trash, right? This is the idea of hashing, and this is how we maintain data integrity, okay? And the final one, the final term that is important to know is the non-repudiation. So what that is? Let's say if you want to buy a house, for example, right, and you sign a contract that you're buying this house, what prevents you from 1 year later, what prevents the previous owner of the house 1 year later to say, oh, I didn't sign this contract, so the house is still mine? Well, what prevents him is that he signed a document, and this document, it's owned by both parties, so he cannot say that he didn't sign it, right? So the information that he provided, he cannot just say, no, I didn't do that. Okay, he have to own what he did. So this is exactly the same in the networking space. So we need to make sure that if some message was edited by somebody, or somebody took some action, over the communication with somebody else, we can trace the message back to the source, okay? And this is where this term comes from, okay? We achieve this using, again, encryption and something called digital signature, okay? So everybody that is sending a message will have some digital signature, whether it's gonna be IP address, MAC address of their device, a combination of both, port number, and so on. Okay, so those are the three terms that are quite important to know. Yep.
So with non-repudiation, does that mean that I have to include that in some kind of software or sending protocol, or it's nice to do that, and a person should do that, but maybe they don't have to do that?
So this is something that is happening pretty much on the background when you're using different applications that communicate over the internet. For example, if you send a message to somebody, let's say in Twitter, let's say you write something in Twitter, right? Later on, let's say if we go to the court and there is some like lawsuit against you writing this message, they can trace this message to you and they can prove that you sent this message, okay? So this is something that is happening in the background. You don't need to do anything about it. Of course, you can, like, there are some websites in which you can go and write like a fake email, fake name, those type of things. Then it will be very hard to track the message to you, right? So this is what I mean by this. Also, the email communication is also another proof of that. That when you send an email to somebody, this is also a proof that you sent this email, right? No, not somebody else.
Okay, thank you.
Yeah, no problem. Yeah, and also another ways to prove that, of course, is obviously if a message was sent from your account, from your network, from your IP address, and from your device, the chance that somebody else sent this message is very low. Okay, so we're not going to go into too much depth on the security standards because there are many of those, but the most popular standards in the security space, they're the ISO, right? And the NIST framework, okay? Pretty much they determine the security standards for many agencies. Of course, it really depends on the purpose of the business, on what security standards they are going to use. For example, a bank might use a very different security standards comparing to a university network. And when I say standards, those are pretty much guidelines on how communication should appear. Should we allow, for example, how many administrators should we allow in a network, and so on. Usually the less administrators you have, of course, the better is, because you have less points of access. But yeah, there are agencies in US, in Europe, worldwide agencies that are involved into defining algorithms for cybersecurity. So in the course, we're going to look at some of those protocols, but we're not going to focus on a specific standard, right? So as you can see here on this table, I have some security standards based on service type, right? So you can see and make the difference. For example, we have in the network authentication, right? We have one security standard for the TCP IP communication. We have the IPsec standard, which is protecting the IP addresses. When we're transmitting emails, there is a standard called S-MIME. So MIME is a protocol that helps us to write rich emails, right? So that way we can filter emails, we can add some, design on the text there. And the S-MIME is pretty much the protocol that protects the emails from being seen from unauthorized people, right? And so on. I included this table here so you can really, if you want, use it as a reference, okay? And of course, the other very important protocols are those that are protecting us when we communicate over the network, which are the SSL and the TOS protocols. We're going to look into those a little bit in more detail later. Okay. Yeah, and this is just another slide, so you can see actually I covered the most popular security protocols. So this is the public key cybersecurity, right? The MIME protocol and the SSL. Okay, so what you can see here is, as we said already, it really depends what security standards we implement on what is the size of our organization and what is the purpose, pretty much. Okay, so we already said that in the operating system we pretty much rely on the security from those systems, right? So the Unix, Linux, and Windows system is going to be responsible for the operating system security. To secure applications, we're going to use virus protection software. There are many different ones. I just included one of those here. Okay, so we have email, firewalls. So the firewall, I will briefly explain. Firewall is something that removes pieces of your hardware and software from the public, right? So for example, your keyboard and your mouse is protected by the firewall. Okay, so nothing can access it from those. You can just introduce commands into your device, but nobody can introduce commands to those specific pieces of hardware that you have. So this person doesn't get access to your actual device. Okay, but we're gonna have like a complete lecture on the firewall, so we're gonna look into it in a little bit more detail. Yeah, so those are some of the security best practices. I'm sure that you're familiar with most of those. Okay, what is very common these days is the phishing, right? So just because now the attackers find it very hard to penetrate into certain systems, they are sending phishing emails to people so they can write their password or any other information so they can get access to a specific system. Okay, one way to prevent that is obviously two-factor authentication, where you have two ways to authenticate yourself to a specific system, right? So yeah, you can review those. Yeah, they're pretty good. Okay, So finally, we're going to talk about the security threats, okay, or what are the different types of security attacks that we need to prevent ourselves from, okay, um, and what are the measures we can take to actually do that. Okay, so first of all, before explaining them, does anyone of you know some of those types of attacks? For example, the DOS attack is a very popular one. I don't know if you've heard of it or any others. So obviously the phishing, I already explained it.
With the insider threat, is that would you say that one's maybe the most difficult to do anything about? If a person just decides if they have access and they change their mind to do something that they shouldn't do, is there really no way beyond that other than trust?
Yeah, exactly. And actually, good that you mentioned this because um, just because of the research on the insider attacks, right now, companies, they don't just give access to all their employees to all the information. So depending on your position, you get access to specific details. That way, first of all, you cannot have full control over the business, and second of all, of course, if it happens that you want to do some damage to the company, this can be minimized, right? Because you have less access to data.
So what if, for example, there's a company that maybe they don't quite understand, like I mean, a big corporation, of course, they would have a very good security team to and understand that insider threat is an issue, but I don't know, I guess, what are some suggestions you might have for smaller companies that maybe they have all good intentions for having maybe a network administrator, but they don't understand that they also need to keep that secure?
Yeah. So the first thing I can give, like from my own practice, right? I have a friend that he's working in a small company. It's 10 people, this company, right? And obviously they don't have like very advanced security systems, those type of things, right? What they do is they're really dividing the information based on the roles. So for example, my friend, he is a software engineer, so obviously he doesn't have access to the financial information or any other information that is not tightly related with his work, okay? Also, they have only one administrator that is able to administrate all the systems. So they have only one root user, which means that the root user can access pretty much everything, right? So this is another very good practice, yeah. What else? So, yeah, and also another thing, if you're using only renowned applications and you're checking those and you're working just with third parties that you trust, the chance that you're going to have troubles with those third parties is very low. Also, I don't know if you've probably heard these guys, but there are many companies that when they promote themselves, they say, okay, we are ISO whatever standard it is accredited, which means that now if somebody decides to work with that company, I know that they meet this standard, so there are certain things I'm not going to expect from this company to do to me, right? So I expect some bad practices are not going to happen with this company, let's say. So yeah, those are some good practices. Now let's talk for the other threats. So the malware, this is the most basic one. This is how you can imagine a virus, okay, going into your device, messing up your files. Malware is pretty much a software that is designed to harm a computer system. Okay, those are worms, Trojan horses, those type. Okay, phishing we already talked about. The zero-day attack. So, for example, if I have a Windows and I'm a hacker and I explore the weaknesses of Windows, so I see all the files of the operating system and I notice that there is a weakness in some of the files, I can do zero-day attack, which means I know that on another device those files are also going to be vulnerable and I'm going to attack specifically that vulnerability. Some of the operating systems, for sure I know that Linux does this, they have a page with recently found vulnerabilities into their softwares, since it's open source, so everybody can look into the source code, okay, and they have page with recently found vulnerabilities, so people were aware of that. A very interesting attack is the DDoS attack, okay, and this has nothing to do with us being able to get information, receive information, and so on. In this type of attack, we just try to take down the server, okay? So when we're communicating over the web, which is pretty much what we do most of the time with our computers, we request something from a server, right? The internet works in a client-server based applications, right? So you're requesting information from the server gives you this information, okay? So DDoS attack is the attack that overwhelms the server. And we're gonna look in a specific example. So let's say if I send 1 billion requests to a server and the server is not capable to cope with so many requests, the server is going to shut down, okay? And it's not going to be operative anymore. And finally, there is the cyber warfare, and this is more of an intelligent cyber attack, right? So this is cyber attack that will be done to achieve some political or military objectives, right? So this is some very advanced attack done by professionals hired in an organization to do specific damage. Okay. Now, as I said, in these days we have a lot of protocols that are helping us to have like a really secure communications, but recently the design philosophy of many applications are actually stimulating the hackers to explore vulnerabilities. So these days softwares are made to be more and more simplified for the user, so the user interface is very easy to understand. Also, many of the applications are starting as open source project, right? So let's say if I want to start a business and I don't want to do it on my own, I can create a project in GitHub and then make other people excited about this project, and we can all work on it, okay? That way somebody can introduce or somebody can find vulnerability into your code and easily assess your application from there. And this is the negative side. The positive side on that is that they're also good people, so hacking these days is not only a bad thing. So there are hackers that are working specifically for resolving those vulnerabilities. If I'm a hacker and I see there's vulnerability in a system that I want to help building, I will make sure that I remove this vulnerability, right? So I would say this is more good than bad thing, having all this information, because they are more good than bad people. So if the good people put their brains in to resolve those vulnerabilities, we can work together, so applications are more secure. Okay, and now we're going to talk specifically for client-server communication and how it is possible for communication to be intercepted. I will just give you a simple example, okay? So, as I said in the beginning of the lecture, when we communicate over the internet, we're pretty much transferring packets, okay? So when you want to send a message, this message is broken into small pieces of information that are called packets, and those packets are sent through the web. or through the channels of communication. Okay, so I don't know if you're familiar with the OSI model, but this pretty much determines a different level of communication. For example, the first layer is the physical layer, so those are all the wires that connect our devices. Then we have the data link layer, which is pretty much the interfaces or how the devices get connected together. Okay, then we have the network layer, which is pretty much the IP address, right? So how we communicate network to network. Then we have the transport layer, okay, which is the entry point to every application. If you heard of a port number when you want to communicate with somebody else, you open a port, they open a port, and through this port, two applications can communicate. This happens in the transport layer. And finally, in the application layer is where the application does its actual work. So what I'm trying to say is that the work of the application layer or of the applications is very much dependent on all the layers below, and specifically it is the most related with the transport layer. Okay, so in the transport layer we have two main protocols. Those are called TCP and UDP. So before continuing, have you heard of those protocols? Can somebody tell me anything about those? Or you haven't heard? Maybe from the other classes, I don't know.
I wonder if anyone has taken it's the data network class. I took it last semester.
Okay.
Or last summer. So it's been a year now. I remember the terms, but I wonder if anyone else, have you recently taken in?
I was actually having data networking last semester. So if I would see some student from this class here, I would definitely ask them, right? Just to make sure they were listening. But okay, maybe you haven't. I mean, even if you heard, maybe you haven't. You don't remember, or sometimes when you don't work with something, it just gets faded. So that's fine. I will explain very briefly. So what you need to remember is that UDP is unsecure, TCP is more secure. UDP doesn't establish connection. TCP establish connection before transmitting the packets. Okay, so you would use TCP if you want to transfer files, right? So you first establish connection, you make sure that no packets have been dropped, or if they've been dropped, you send them again. It's all good. In UDP, we're just shooting packets without establishing a connection. So if some packets are dropped, we'll never be able to find them. Where are we going to use UDP? Obviously, right now when we're talking in face communication, for example, if my internet is slow, the quality of my picture will start deteriorating. Why? Because some of the UDP packets are going to fall off, right? And respectively, the quality is going to get worse. But UDP is like way easier to manage specifically for those services. It's more light. If we would be using TCP, we might get like better quality, but the connection might drop at some point. Okay, so this is the main difference. So what I'm trying to say here is that based on the UDP and the TCP protocols, the application layer can be very secured or not that secured. And I'll give you an example. So for example, in TCP, we have three-way handshake. What that means? The client first sends a packet to the server receives the packet, and it sends SYN, acknowledge message, which means that the server says, okay, I acknowledge that you contacted me, so I received your message. Now I want you also to acknowledge that I acknowledge, right? So then the client sends another acknowledge message. connection is established and we can send as many messages as we like. So what's the vulnerability here? So while we're establishing this process, the ports, so in the transport layer, we communicate with the ports, okay, with the port numbers. We open port from the client, we open port from the server, and we send all of those messages to the ports. Now, before this process is finalized, the ports are partially opened. For example, if the client sends the SYN message, right, the server replies, then somebody else can intercept this SYN acknowledged message and send its own acknowledged message with information about their IP address, communication, and so on. So now the server will think that it's sending the information to the client, but in fact it's going to send the information to somebody else. Okay, so this is one example from the applications that we're using every day with possibility, to be intercepted by attackers. And here I left some other examples. So normally for those type of attacks, people are scanning ports. Okay, so we're going to scan the ports of a specific server and we're going to try to intercept messages. Okay, so we can do the TCP SYN scan, which is this message right here. We can do a UDP scan, and there's another protocol called ICMP echo scan. Okay, so this is another way to intercept packets from the ports. Okay, so this is, of course, this is something that now has been very minimized because of the SSL protocol, right, the secure network protocol. But sometimes it can give us a trouble. So I have another question for you guys. So you know that when we're going to a website, normally we type HTTP. You've seen that, right? So there are two ways. Sometimes we write HTTP, sometimes we write HTTPS. Do you know what is the difference between those?
HTTPS is more secure.
Yes, correct. And it is more secure, yes. And why? Does anyone know why it is more secure? So the reason that is more secure is that HTTPS means HTTP plus SSL. SSL was a security protocol that we saw earlier. So this means that if you enter a website that starts with HTTPS, when you write something in a field there, first this is going to get encrypted, then it will be sent to the server, and then the server will decrypt it. So along the way, nobody will be able to understand this message unless it has the same security key. Okay, if you send a message only with the HTTP, which HTTP is the protocol for web communication, right? If you use only HTTP, if somebody intercepts the message, this message is not encrypted and they can get your data. So one advice I would give you is never, in no circumstances, add any credit debit card information or any personal information in websites that are only HTTP, because your information is not encrypted and anyone can get it. Okay. We're, by the way, going to explore exactly that, so I'll show you in the next lectures how you can use Python, to get a message, encrypt it, deliver it, and after that decrypt it using security keys. Okay, there are many very nice libraries which does the work instead of you. Okay, so yeah, those are pretty much some of the things that I was talking about, the denial of service attacks, the port vulnerabilities. Okay, so yeah, those are actually the major types of attacks that are still happening. Okay. Okay. So in the recent years, I mean, not only recent, but since the internet has been built, obviously the cyberspace is growing a lot. Okay, so they even say it's growing with 64% year by year. Okay, so there are 400 to 500 new viruses being produced every month, 250 vulnerabilities into the computer programs, and this is by a single research, right? The good part is that also at the same time there are people that are resolving those vulnerabilities, which maybe some of you are going to do that one day. Okay, so this is why we get this level of security and we feel secured when using internet, right? Another reason for those numbers is the fact that now they are hacker organizations. Before, in the years of 2000s, there were no hacker organizations. Those were individual people, that just like to code and to experiment, and or actually in most of the situations where there has been a single hacker, this is usually a teenager that just wants to play with software and see what they can do. But now these days, there are hacker groups. Do you know any of those? There is one that is a very famous one currently. They're called the Anonymous, right? With some masks, white mask, mustache, if you've seen, right? So there are many websites. I think let me see here. Yeah, hacker.org was a website that hosts those communities. So yeah, there are quite a lot of those. Okay, so finally, and those are just some examples. I'm not going to add any of this on the quizzes, but I'm just going to mention some of the hacker attacks that were happening, throughout the years. Okay, just so you can get some context. So, for example, imagine in 1988, these were the years where the internet was just produced. Okay, there was a guy that created a computer program. So I think initially he didn't intend for this computer program to be a virus, but the virus went from a device to a device, firstly damaging all the computers in MIT, which is actually close by, right? And then moving to everywhere in internet, right? So it could get pretty much in every device that it can get. It damaged about 6,000 network computers, okay, and caused like a very big problems even on government agencies. Okay, so I think in the end it caused damages, as you can see, of about $96 million. Okay, and this is just when the internet was created, right? So it's interesting. Then there was the Marcello virus, which was actually using, yeah. Oh, okay, yeah, no problem, got it. Yeah, so then there was the Marcello virus in 1991, okay, which was actually using another type of attack. So they were using the floppy disk, okay, and the hard drives. So, for example, this virus would get in a floppy disk that is in a computer. I don't know if some of you remember the floppy disks. When I was a kid, we still had them. They were looking something like, maybe something like your phone, maybe a little bit wider, okay? So it's not like a typical disk. It was more square one. So through those type of hardware, so when you when you put this piece of hardware inside your machine, the virus were getting into your system. Okay, so I'm going to move a little bit forward here and go into one very interesting attack. Okay, so yeah, this attack actually was one of the first DDoS attacks. Okay, so this guy that had the nickname Mafia Boy, actually this was a pretty big case in US. He created DDoS attack that targeted initially the Yahoo servers. Okay, so he didn't gain any access to their servers, but what he did, he created a virus that goes to different computers around the world over the internet, and it asks each of those computers to send the request to the Yahoo servers. Okay, so even if Yahoo will have some prevention if multiple packets or multiple requests are sent from the same computer, okay, they won't work because this virus would go to different computers. They will send requests to Yahoo, and at some point there will be millions and billions of requests to Yahoo, so they will have to stop and shut down their services. So this guy took them down for 3 hours, and later this year, it's interesting that he took down eBay, Amazon, CNN, and other companies as well. Okay, so he was, let's say, one of the pioneers into to this type of hacking. Okay, so pretty much that was everything, guys, that I want to share with you for today. Of course, bear in mind on those three things that are these days the major security vulnerabilities that you can get. So the insider effect, so most of the vulnerabilities these days come from somebody that is insider. The social engineering, which is how we're getting phished from our emails. Even me as a person that have some literacy on software, I've been once actually very close to be phished as well. So the hackers, what they did, they sent me a message, and when I opened it, it was having exactly the same interface as my banking application. So normally when you see the interface of application that you use, the first thing is to write your password, right? So I was very close to do that, but I didn't do it. I'm just trying to say that nobody's protected from this social engineering phishing attacks. Okay, so yeah, this is going to be pretty much everything for today. All right, so yeah, thank you guys, and I will see you next week. All right, have a good day.